In this video, we will factor the trinomial 12x squared plus 11x minus 36. Remember, the first step in any factoring problem is to factor out the greatest common factor, but in this case, the only common factor among all three terms is 1, and therefore if this trinomial does factor, it will factor into two binomial factors. Let's set up the parentheses for two binomial factors. Next, because the leading coefficient is not 1, it's 12, remember we are not looking for the factors of negative 36 that add to 11. Again, that's only true when a, the leading coefficient, is 1. So for our first step, we need to place the factors of ax squared, which in our case is 12x squared, into the first positions of the parentheses, or binomial factors. But in this case, notice how there are several factors for 12x squared. We could use 3x times 4x, 6x times 2x, or 12x times x. Let's make some additional sets of parentheses here on the right. Let's use 3x and 4x in the first set, so we have a 3x and a 4x in the first positions. For the second set, let's use 6x and 2x. And for the third set, let's use 12x and x. Next, we need to place the factors of c, which in our case is negative 36, into the second positions until we determine that the sum of the inner product and outer product is equal to the middle term of 11x. So we need to find the sum of the inner product and outer product for each set of parentheses, here as well as here. Let's go ahead and list all the factors of negative 36. We have negative 1 times 36, negative 2 times 18, negative 3 times 12, negative 4 times 9, negative 6 times 6. Going back up to the top, we could also use negative 36 times 1, or negative 18 times 2, negative 12 times 3, and negative 9 times 4. So we do have a lot of factors to try, but keep in mind, when we place these factors into the binomial factors, none of the binomial factors can have a common factor other than 1, because if it did, there would have been a common factor other than 1 in the original trinomial, which means you don't have to try negative 6 and positive 6, because if we did use these factors, notice how at least one of the binomial factors would have a common factor other than 1, which can't happen, again, because we don't have a common factor other than 1 in the original trinomial. So we can go ahead and forget about these two factors, and let's try the negative 9 and positive 4. So using the factors of negative 9 and positive 4 for the second positions, we could not put a minus 9 here for the negative 9 because we'd have a common factor of 3. So let's put a plus 4 here for the positive 4. And then for the second binomial factor, we'll use the negative 9, giving us minus 9. Notice how we also could not have used the plus 4 here, because if we did, we'd have a common factor of 4. Looking at the second set of parentheses, notice how we can't put the minus 9 or the plus 4 here, because we'd have a common factor of 3 or 2, and therefore we can go ahead and skip this set of parentheses. Let's go to the 12x and x. Again, we can't put the minus 9 here because we'd have a common factor of 3. We also can't put the plus 4 here because we'd have a common factor of 4. So we can go ahead and skip these factors and just check the sum of the inner and outer product for this set of parentheses. We'll notice how the inner product is 4 times 4x, which gives us 16x, and then we have plus 3x times negative 9, which is negative 27x. 16x plus negative 27x is equal to negative 11x, but we want positive 11x, but this is an easy fix. Because we have the wrong sign here, we can simply change the signs of the factors of negative 36, meaning we make this minus 4 and this plus 9. Let's make that change and check it again. So minus 4 here, plus 9 here. Notice now the inner product is negative 16x, plus the outer product is positive 27x, which does give us a sum of 11x. And we quickly found the correct factorization for the given trinomial. So we go ahead and erase everything else. And we now know this is the correct factorization. So even though there were a lot of options using the trial and error method, by knowing that we could not have a common factor and a binomial factor, we were able to eliminate a lot of the options. Let's go ahead and check these factors by determining the product. We have the quantity 3x minus 4 times the quantity 4x plus 9. To multiply, we have 4 products, 1, 2, 3, and 4. 3x times 4x is 12x squared. 3x times 9 gives us plus 27x. Negative 4 times 4x gives us minus 16x. And negative 4 times positive 9 gives us minus 36. Combining like terms, we do have 12x squared plus 11x minus 36, which was the original expression verifying we do have this factored correctly. I hope you found this helpful.